So whenever you must always start with the master identity. The one we call master identity. Okay. This guy. Like if you square sign and then you add the squared cost, you always get one. This is the master identity because from it, we are able to write so many of them. So look at this. Look at this. If I divide this whole thing by 4 squared, I divide by cos squared, I divide by cos squared, we are getting another identity. Sine squared over cos squared. Cos squared over cos squared is 1. And 1 over cos squared. So we have another identity. Like that. Again, the very guy, if I divide it by sine, if I divide it by sine, okay, I would get 1 plus cot squared x equal to cos x squared x. We get those. So these 3 identities, they help us a lot. So many of them. And also, from the very one, we can take cos the other side. Okay, we can take sine the other side. Like that. So if you combine these with some of the double angle, half angle, you then start driving so many things. Okay, what is key to mention also are the components. Can I say A plus? I'm going to get sine A cos B plus sine B cos A, like that. And then if I get cos A plus B, this guy is going to be cos A cos B, sine A sine B, like that. Okay, so if where there is A and B there, I decided to put A plus A. I'm going to have cos 2A, like that, which can be expanded because I'll put A squared A minus sine squared A because there will be A here. You see? Now I can write this in any way because I know that what was cos 2A can now be written in cos form alone. So I'll have cos squared A minus, what is sine squared A? Sine squared A is 1 minus 1, like that. And this can be simplified to 2 cos squared A minus 1, like that. So you can write it in several ways. Several ways. You can go back in the same cos, put A, and put what is cos, you put sine. Come out in sine. Okay, if we did that, we'll have cos 2a coming out as 1 minus 2. Now, identities can be nice if you're just doing them like that. Now, let's see examples of how do they ask them. Let's see. Let's pick examples. Examples, we are going to question 7 of the Torah sheet. Prove the following. A, we have 4 cos 3x minus 3 cos x is equal to cos 3x. So, if I'm given such, it's very difficult for me to compress this to that. But it's easier for me to expand the cos 3x into the separated one. So we'll start with the right hand side. So we'll pick the right hand side and say, we know that cos 3x can be written as cos 2x plus x. And then expand. This will be cos 2x cos x minus minus sine 2x sine x, like that. Okay? Then we can expand further. Cos 2x can also be written as cos x cos x minus sine x sine x. I've done that derivative, and then cos x minus sine 2x can also be written as let's go back. What is sine 2x? We didn't drive that one, right? Sine 2x, it's sine x cos x plus sine x cos x. Meaning we get 2 sine x cos x multiplied by like that. And then we come back. So this guy is cos squared, so it's going to be cos 3x because you're multiplying by this. Minus sine squared x cos x minus 2 sine squared x cos x. And then from there, we change this guy. As you can see on the left hand side, we don't have any sign. So we change whatever is sign. So we have 3x minus 1 minus cos squared x cos x minus 2, 1 minus cos squared x cos x. And then now we have cos cubic minus cos x plus cos cubic minus 2 cos x plus 2 cos cube x. So we can add this guy plus this guy plus this guy. We get 4. This guy, that guy, we get minus 3. If you check this one, we have our minus 3. Okay? This means that we are 4.
Yeah, I'm lost.
Where are you lost?
Where did the minus sign 2x times sin x come from?
The minus 2.
Minus 2x times sin x.
This one.
On top.
This one.
Yes.
So we were expanding. Remember we said that cos A plus B is equal to,
Oh, we're using that one.
yes, we're using this. Now tell me, what is my A? So this is our
The
A,
A is x.
this is our B. You get it, right?
Uh,
All right. So that's how we get to solve most of these issues. Okay, they are simple in nature. It's just that we get scared when we see powers. Let's pick another one. B. B is cos x over 1 minus sin x equal to tan x plus sec x. Like that. So we want to solve this. There are so many ways we can do this, guys. If we want, we can go to the right hand side. Or we can go to the left hand side. Either way. Let's try left. So we have cos x over 1 minus sin x. Then we conjugate this immediately. We multiply it by 1 plus sin x. Also the top by 1 plus sin x. It's going to become cos x plus cos x sin x. So it will be divided by 1 minus sin squared x. But 1 minus sin squared x is what?
cos squared x.
It's cos squared x. So if we do this plus cos x sin x over, cos squared is the same thing as cos x, isn't it? So you see, this cos can go with the power. So we have 1 over cos. This cos can go with this. So we have sin over cos. What next? Sin over cos is tan. 1 over cos is sec, which is what we have on the right hand side. You see that?
Yes.
Anything? No issues, is it?
No.
Okay. Another one.
Oh, this is issue.
Choose, yes.
After you divided by 1 sin x, you said it's cos squared x. Then on the other side, oh, you expanded the cos squared x.
Yeah, just want to say that. One.
Okay.
All right. All right. Okay. So we go to, you can choose also which one are you doing. We have done A. Which one gave you headache?
Hello, your phone is low. It's low. I had challenges with A.
Huh?
Huh?
A done. Okay, let's do it. Sin x minus cos x squared plus
I was saying A. Hey.
A done we are solving.
Yes, we can play this one.
Hmm?
Yes, we can solve this one.
Okay. So how do we okay. You start from the left side. You expand. So we have sin squared x minus sin x cos x plus cos squared x plus sin squared x plus 2 sin x cos x plus cos squared x. Okay. Then now this one and this one. And then we have sin squared plus 1 plus sin squared plus 1 equal to, which is the right answer. You see? I don't even know why. Yeah. Let's do G. 1 over 1 minus 5 minus 1 over 1 plus sine should give us 2 tan x sec x. We start from the left hand side. So 1 over 1 minus sine x, we multiply by, not necessarily multiply. So let's just do the part. The common denominator is 1 minus sine x, 1 plus sine x. And then up, we have 1 plus sine x minus 1 minus sin x. So that the ones will go, and then we have 2 sin x over, we conjugate. We conjugate, we're going to have 1 minus sin squared x. But we just expand, not conjugate. So this is 2 sin x over 1 minus sin squared is cos squared, which is cos x. So we get 2 sin over cos tan. 1 over cos sec, which is the right hand. So there's no identity that you must fulfill because all the identities are, if you have those 3 identities, okay, and the compound.
Can you eat?
Okay. E. What's E? E is 1 minus cos x over 1 plus cos x equal to tan squared x over. Now we know that, we'll start from the right hand. Tan squared x over 2 is the same thing as sin squared x over 2 over cos squared x over 2. But then sin squared sin x over 2 is equal to the square root of what? The square root of 1 minus cos x over 2. And then cos x over 2 is the square root of cos x over 2. So if we put those here, we are putting them as the square root of 1 minus x over 2 squared over the square root of 1 plus cos x over 2 squared, which is 1 minus cos x over 2 over 1 plus cos x over 2.
The square from where?
Huh?
The square from where?
Where the square one?
Huh?
Look at it. They look at it.
And audible.
I'm saying that if you look at where I put the arrows, are there squares there?
Where?
Here where I put the arrows.
Oh, no.
Yeah, so when you get these and bring them where they are squares, they must be squared.
Oh, okay.
So now we can write this as 1 minus cos x over 2 times 2 over 1 plus cos x, which turns out to be 1 minus cos x over 1 plus cos x.
The twos have cancelled.
Yeah, the twos will go. See.
Okay.
Okay. So you do all the remaining identities. Huh?
The rest, I'll do them.
Yeah, you will do them.
Okay.
Yeah. So let's do the equations now.
Yeah.
Let's do the equations. So we go straight to the example. That's question 1. Question 9. Find all the solutions in the interval 0 to 3. 2 cos 3x is equal to 1.
What
Let's
of question 8?
the same thing as question 9.
Let's pick from both.
We'll come back. I want to have to start with degrees and go to radians.
Oh.
Yeah. So now here we're doing from 0 to 3, right? Then, so we'll have cos 3x is equal to 1 over. We divide by 2 then. Now, we know that cos theta is equal to 1 over 2 when theta is 1. When theta is this means that 3x should be equal to 6. So when we divide by 3, we'll get x to be 20. Now we're looking for all the angles from 0 to 3. So if you look at the quadrant, these are 60 in the first quadrant. Somewhere here in the first quadrant. Where cos is positive. Now cos is positive also in the, it's also positive where? In the fourth quadrant. So we need an angle from the fourth quadrant. So we'll say, okay, then we should have 360 minus 60, which is 300. So that 300 is going to be equal to 3x as well. We divide by 3. So we have another x equal to 100. So in the first step of the quadrant, we have 2 angles. But the space is still very big. We can also opt to go for the coterminal angle. Now, if we went round to coterminal angle, then the first coterminal for 60, you add 360 to 60. This is going to be 420. So you come and say, okay, 3x is also equal to 420. Is equal to 420. We divide by 3, divide by 3. So we get x is equal to what? 3 into 4, 1. Remember 1. 3 into 4. It's what? 4. 3 into 12 is 4. Into 0, get 0. So what we have? We have.
How come we're adding the 360?
Why are we?
Adding the 360 to 60.
We are getting the.
Huh?
Coterminal angle is in the same quadrant.
Yeah, not clear.
Hello?
Yes, now I can hear.
I was saying that we added three cities in order to get a coterminal angle. And coterminal angles are angles that give the same value and lie in the same quadrant.
I'm not hearing clearly.
So I was saying the reason why we added three cities is because we are looking for a coterminal angle.
We're looking for a coterminal angle.
Yes.
Which one is the coterminal angle?
The 420.
Huh?
420. Coterminal angle.
It's in which quadrant?
If I have this angle, right, then I get another angle and end at the same point. These two angles are called coterminal.
Oh.
They are in the same quadrant.
They're in the
Same quadrant. I'm saying we are in the same quadrant.
Okay. As the theta.
As the
As the theta.
I don't get. Okay, tell Manzano.
Okay.